Okay, guys, let's solve this. So, oh, alright. There are k positive integers with base b from 5 to 2024, including both, where b such that the base b integer 2024b is divisible by 16 and 16 is in base 10. What's the sum of the digits of k? Okay, so let's write a general formula for 2024 base b. So it'd just be 20 b. Let's do base 10. So base 10, it's 10, 2 times 10 to the 3 plus 0 times 10 to the 2 plus 2 times 10 to the 1 plus 4 times 10 to the 0. Okay. In base b, that's just 2 times b to the 3 plus, I'll get rid of that, 2 times b to the 2 plus 4 times b to the 0. And this is b to the 1. And then I'll just make this 4. And then we have this entire thing, mod 16 is 0. Now, we could divide by 2, like take out 2. So we just have b to the 3 plus b to the 1 plus 2 mod 8 equals 0. So we need this number to be divisible by 8. I'll get rid of the 1. So how many numbers 5 to 2024 are divisible by 8 in this way? Okay. Can I factor this? B times how do I factor trinomials? I don't know. So let's see. B cubed b cubed and then 2 and this gives me b squared. This will give me b, then let's say this gives me 1 and we'll get up to 2 here. So 2b squared, and then here I get, I'll write that better. Here I get b. So for b to be 1, this has to be 0. And then this has to be 0. Because this would be 0. So that doesn't work. Let's try when this is 2 and this is 1. So then we have 2b. Here we have b squared. Here we'll have negative b squared. And here we'll have, so negative b. Here we'll have negative b. Yeah, that works. So this is equal to b squared minus b plus 2 times b plus 1. Okay, and then can I further factor this? Two things that multiply to 2 that add to negative 1? No. I can't. Okay, so our three possibilities is that this is equal to 4. This is equal to 4 times 2 8 times 1 or 2 times 4. Guys, I'll be right back. Sorry guys, I just brushed my teeth and stuff. Anyways, back to this. So 8, 1, 4, 2, 2, 4, and 1 times 8. Okay, so let's see. This is only gonna increase, so there's only gonna be a finite number of values where it's in this range, which I mean, I guess makes sense. But let's try a number. Let's try 5. So we get 25 minus 5 plus 2, which is 22, and this gives us 6. Okay, let's try 6. 36 minus 6 plus 2 is 32, and then this is 7. I wrote this wrong. This is not gonna, this just has to be divisible by 8. This isn't gonna equal 8. So, okay. So these just have to have the factors of 2 cubed in here. 2 cubed. And solely 2 cubed, or 2, 6, or 2, 6, or 2 to the 9. Like this. Okay, so this is gonna be odd. B is odd, because this has to be even. Okay, let me try. This is going to be 1 less than a power of 2. B equals 2 to the n minus 1. So that gives us for B 7. These are our possible options from this: 7, 15, 31, 63, 63, 127, 255, 511, 1023, and that's it. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, I can't count. 1, 2, 3, 4, 5, 6, 7, 8. How did I get this wrong? If there's only 8, then the sum of the 8 at maximum, the sum of the digits can't be any of these. What could I have possibly done wrong? 2 times b to the 3 plus 2 times b to the 1 plus 4. Still less 16. Divide out 2. Mod 8 equals 0. Yeah. But let me try to factor this. Again, b cubed minus b squared plus 2b. B squared, those cancel out. You got 1b and 2. What? Oh my god, I'm such an idiot. If it's mod 8 equals, if it's divisible by 8, it doesn't have to be a power of 8. It just has to include those factors of 2 cubed in there. Oh my god. Okay, so let's try that again. We get 6 here, when it's 5. Then we get 22. 22 times 6 is 132, which is not divisible by 8. 5 gives us 132. 6 gives us 32 times 7, which of course is divisible by 8. 7 gives us 49, so it would be 44 times 8, which is divisible by 8. 9 gives us 81 minus 9, so 72, 74 times 10. I forgot to do 8, but I'll do that in a second. This is 2 times 37, and this is 2 times 5. So this doesn't work. 9 doesn't work. 8, 64, so 58 times 8, times 9. 58 is 18 above, so this has no factors. 58 is 18 above 40, so it's not even divisible by 4, so no. It would be 192 times 11. 92 is divisible by 4, but not by 8, I believe. Divide this by 4, you get 23, and that's not divisible by 8. That's not divisible by 2, I mean. So 10, 11, 121 minus 11, we get 112 times 11. 112, let's see, it's divisible by 4. Yeah, you get 25, so 28. Yeah, it's divisible by 8. Interesting. So, this is difficult, because this is like a complex equation, and I don't know when this will give something that's 8, that's divisible by 8, divisible by 4, divisible by 2, and this will give something that's divisible by, oh, 1, and this gives something that's divisible by 1, 2, 4, or 8. I don't really know. Well, I can at least tell that right below multiples of 8. So here, this gives us sorry, this when it's like 7, 16. So it's gonna be 8n minus 1. Let's see, is equal to 2024. So 8n is equal to 2025. How many? It's gonna be like 8n. What is 2024 multiple? 2024. So we have 100 isn't, which means 1,000. I don't think it is. Yeah. So this isn't. I think 122 is, 1022 is. We get 600 plus 4. It doesn't go into that. No, I think it does go into this. This would be, what does this give me? 200, 400, which would give me times 550, which would give me then 3 at the end. So 253. 253, adding the digits together, we get 2, 5 is 10, plus 3, no, plus 2, 5 is 7, plus, okay. So, I'm gonna say it's good old 20, because I don't really know what it's getting. I spent too long on this question, so I don't really know. I'm gonna guess 20. But I feel like I've made significant progress on this. And remember, it's not always solving the problem that's the goal. It's just making progress on it. You know? So, let's check the answer. Where's the answer? Here. The answer is 20. So I got this right, question mark, but it was just a guess, pretty much. What did they do? They factored it, which is, yeah, what I did. Oh, so they found that if b is divisible by 3 or 6, then this is divisible by 8. Interesting. Okay, well I can't go through the full solution, but I kind of got it right. So, thank you for watching. I'll see you guys tomorrow. Goodbye.